Okay, this is our last part of our review for our exam. So the first one in this has simplify some radical expressions with a negative value. Now remember, negative square roots, square root of negative 1 gives us an I. So if I look at the square root of negative 80, the negative sign gives me an I. So this becomes I times the square root of positive 80. And then of course I could break down the square root of 80. So 80 is 8 and 10. 10 is 5 and 2. 8 is 2 and 4, which is 2 and 2. So if I look at this, I have two groups of 2 that can come out with a 5 left over. So I could take those two 2's out front. I'll just join the I, which I already took out. So we have 2 times 2 times I, and then we have the 5 left over. So this becomes 4I times the square root of 5. So the one next to it, number 2, is very similar. We have the negative square root here. So I can take that out, so that'll become I times the square root of 175 x squared y cubed. So now I'll try to break down that 175. So 175 I know is 7 and 25, and this is 5 and 5. So again, I have one group that comes out. So I can take a 5 out, so that'll become 5I, and a 7 left inside. And then we have to still deal with the variables, but that's okay. So we have x squared, so I think, okay, how many groups of 2 do I have in x squared? Well, I have one group of 2, so I put one x on the outside, none left inside. For y cubed, I have one group of 2, because it's y cubed, and then I'd have one left over. If you have 3 people, you have one group of 2 and one left over. So this simplify would be 5ix times the square root of 7y. Okay, so we have a couple operations on complex numbers. Now complex number operations really work just like polynomials, if you recall. So subtraction of polynomials, we turn to addition by distributing the negative. So if I distribute the negative 1, this becomes negative 13 and plus 7i. Now I can combine like terms, so 3 and negative 13 is negative 10. 2i and 7i is 9i. So very important, the key thing here is it's just like terms. All right, let's look at number 4. 4 is multiplication of two complex numbers. We have 1 minus 2i, 4i minus 9. So when I have this, I will typically FOIL. And remember that I squared, if I ever get that, I squared is negative 1. So if I FOIL, 1 times 4i is 4i. 1 times negative 9 is negative 9. Negative 2i times 4i is negative 8i squared. Negative 2i times negative 9 is plus 18i. So this guy right here is going to become negative 8 times negative 1. Because remember, an I squared is a negative 1. So I can rewrite this as 4i minus 9 plus 8 plus 18i. And then just combine like terms. So my numeric part, negative 9 plus 8 is negative 1. My I part is 4i plus 18i, which is plus 22i. Alright, so the second 3 problems deal with solving quadratics. This is obviously a really big part of our exam because this is a really big topic we've covered for quite in depth. So it says solve these by any method, and on your exam you can really solve them by any method. So most people will probably default to the quadratic formula, which is negative b squared plus or minus or negative b plus or minus b squared minus 4ac all over 2a. So we'll put that there. So if you have it in standard form, you could use this. Okay. So let's try this with this problem. So this has an a of 1, a b of 9, and a c of 20. So if I plug this into the quadratic formula, negative 9 plus or minus the square root 9 squared minus 4 times a times c all over 2a. So if I simplify this, this is negative 9 plus or minus the square root of something over 2. So our discriminant inside here, 9 squared is 81. So we get 81 minus 80 for our discriminant, which is going to be 1. But the square root of 1 is just 1, so this is negative 9 plus or minus 1 over 2. So this gives us two answers. We have negative 9 plus 1 over 2, negative 9 minus 1 over 2. So negative 9 plus 1 is negative 8 over 2, which is negative 4. Negative 9 minus 1 is negative 10 over 2, which is negative 5. So two answers like there typically is for a quadratic. Alright, so let's practice this a couple more times. So we have this quadratic here, which a is 1, b is negative 4, c is 11. So we will use our quadratic formula. So negative negative 4 is 4, plus or minus the square root, negative 4 squared, minus 4 times a times c, all over 2a. So this is going to be 4 plus or minus square root of something over 2. So our discriminant, negative 4 squared is 16. 4 times 1 times 11 is 44. So we have 16 minus 44, which is negative 28. So when I simplify my root, I know I take an I out from my negative 28. And then I can try to break down 28. So 28 is 4 times 7. 7's prime, 2 and 2. So I have a group of 2's I can take out with a 7 left over. Now if I look at all the numbers here, if I could divide them all by the same thing, I should. In this case, I could divide them all by 2. So this becomes 2 plus or minus 1i radical 7. Over 1, but I don't need to write the over 1. So 2 plus I root 7, 2 minus I root 7. Okay, let's look at number 7. Number 7 says, we're solving still, so we have a is 3, b is negative 8, c is negative 12. So our quadratic formula is going to say the opposite of negative 8 is 8, plus or minus the square root, negative 8 squared, minus 4 times 3 times negative 12, all over 2 times 3. So same idea, so we have 8 plus or minus the square root of something over 6. So negative 8 squared is going to be 64. Now for our numbers here, we have two negatives. We have a negative 4 and a negative 12, so it's going to be plus. We have 4 times 3 times 12, which is 144. So we just take 64 plus 144 and we get 208. So now same idea, we'll try to break down 208. 208 is going to be 2 and 104, which is going to be 2 and 52, which is going to be 2 and 26, which is going to be 2 and 13. So I have two groups of 2 and a 13 left over. So of 8 plus or minus, we have two 2's, which are 4, root 13 over 6. So now I'll just look at these numbers, and I see they all do divide by 2. So this will be 4 plus or minus 2 root 13 all over 3. Very good idea to be very well prepared and well versed in these quadratics. Okay, what is the discriminant of x squared plus 5x minus 1 equals 0? Well, the discriminant always is just the b squared minus 4ac part of our quadratic formula. So our discriminant in this case is 25 b squared minus 4 times a times c. So this is 25 plus 4, which is 29. So what kind of roots does this give? Well, it's not negative, so it's not complex. So complex roots have to have a discriminant less than 0, which this doesn't. It doesn't have one rational because that would have to be equal to 0. And it's not two rational because it's not a perfect square. Perfect square would be like 25 or 4 or 9. Anything whose square root is nice. So this has two irrational roots. Now you could obviously also find this by actually working out the problem, but you can actually just do it by looking at the discriminant. Okay, let's look at a couple graphing problems where we're trying to find some parts of the graph. Now, very important, we want to make sure that if it's a graphing problem, we graph it. Because if you graph it, you can see all the cool parts and you really can get most of your information right off your graph. So I've graphed this problem here, and you can see that I just put in the equation y equals negative x minus 3 squared plus 4, and then I've got these really cool parts. So we have this point at the top in this case. This is our vertex. This could also be at the bottom, but in this case it's at the top. We have this point down here, which is my y-intercept. So that's 0, negative 5. And then I have my roots. My roots, or also, of course, my x-intercepts at 1, 0, and 5, 0. Now, we definitely went over algebraic ways to find this stuff, but this is actually a really easy way to find this information. So let's move this over here and answer some questions. So what was the x-intercept? Well, they were 1, 0 and 5, 0. The y-intercept was 0, 5. What was the vertex of the equation? Well, the vertex was 3 and 4. And the axis of symmetry we didn't talk about, but the axis of symmetry is always x equal to whatever the first part of the vertex is. So that's x equals 3, because that's the vertical line that goes through the intercept, or the vertex, pardon me. Okay, let's look at this second graphing problem. Now I went ahead and put this graph into Desmos, y equals 4x squared minus x minus 14. Now the numbers don't turn out to be quite as nice in this case. As you can see from my graph, if I bring it over here, that I have intercepts of negative 1.75 and 2. My vertex is kind of an odd number, and my y-intercept is, you can't really see, it's kind of covered, but it's 0, 14. So not quite at the nicest numbers that we've had. So we'll kind of do this a little more algebraic in this case. So the roots, we saw what they were, but if you don't know what the roots are, we can always solve a quadratic to find these roots, because the x-intercept is always when y equals 0. So really we're just solving the equation 0 equals 4x squared minus x minus 14. And for this we can use the quadratic formula, whatever we want. Okay? So we know from the graph that this is going to be 2 and 1.75, I believe. But you can obviously do the quadratic formula we practiced on the last page. The y-intercept is going to be when x equals 0. So in this case, this makes it really nice. So 0 equals 4 times 0 squared minus 0 minus 14. So that's just going to give us negative 14. That's why I knew the y-intercept was 0, negative 14, even though it was kind of covered on the graph. Now the vertex of the quadratic, if you're not looking at the graph, you want to do it algebraically. Remember, we start by finding the x part of the vertex, which is negative b over 2a, which in this case would be positive 1 over 2 times 4, because a is 4, which is 1/8. So my vertex is going to be 1/8 comma something. So what I do to get the other part is I would just plug the 1/8 into the equation. So that would be y equals 4 times 1/8 squared minus 1/8 minus 14. So this would be 4 times 164, so 4/64 minus 1/8 minus 14. So we could just put this in a calculator. We could keep going. I know this is going to be 1. So since our vertex is 1/8 and 225/16, the axis of symmetry, remember, is always just x equal to whatever this part is. So it would just be x equal 1/8. All right, so this is your final review for your exam. Good luck. If you have questions, please let us know.